We'll continue discussing the amino acids. So we have today glutamine, and the glutamine we uh, focus more on the nickname and the initial because there is a trick here. Glutamine Q, it's like the pronunciation. They just why the initial is a Q, just they maybe focus on the pronunciation because we say glutamine, so its initial it's a Q. So the initial is a Q and the nickname is glutamine. It's just not GLU, no, it's GLN. GLN. And the glutamine, it's not the acidic form. There is something is called glutamine and there is a glutamic acid. So the glutamine here, the initial is Q and the nickname is GLN. Okay, so now we discuss the structure of the glutamine. So this is the carboxylic group, which is any amino acid. This in the black, this is the central form of any amino acid. So this is the carboxylic group, this is the central carbon, and this is the amino group. And then the side chain. So we have another carbon, and the amide group. The amide group is C with the double bond with the oxygen, and there is N nitrogen with the two hydrogen bonds. All of them we call them amide group. So it's a neutral polar, non-charged. That's why we say the neutral. That means it's non-charged and it's polar and essential. So we have to take it from outside, so that is essential, but the glutamic acid it's non-essential, so we have to focus on this. So it's a neutral polar, essential, non-charged, hydrophilic. Why it's hydrophilic? Because it can forms hydrogen bonds. And another reason that it has a amide group and also the central group, so the amide group can form hydrogen bonds, so that it's hydrophilic. And another thing, both asparagine and the glutamine have amide group, so they can form hydrogen bonds as well as with the central carbon. That's mean every amino acid has a amide group can form hydrogen bonds. So if it's form hydrogen bonds, then it's hydrophilic. We will come to the asparagine, but we will notice that there is no carbon here. It just directly to this carbon and then this the amide group, and that is the difference between the asparagine and the glutamine. So focus on the glutamine. So we have this carbon, two carbons, then the amide group, and focus also on the nickname. There is N with the glutamine and the initial is a Q, with there's a trick in the glutamine. Okay, another thing, in Huntington disease, it contains long chain of glutamate. In another word, it's a trinucleotide repeat expansion because too many glutamines. See, we say the glutamines in GLN to be put in Huntington protein and leads to the toxic protein that is lead to the Huntington disease, which is represented by cognitive, psychological and neurological symptoms. What is happened in trinucleotide repeat expansion cause many glutamine, and that is lead to some the disease is called Huntington disease. So that is all about the glutamine. We have to know what is a nickname, is a GLN, and the initial is a Q. We have to remember that there is this amide group, and before it there is two carbons. It is essential, non-charged, neutral polar, hydrophilic, and it associated with the Huntington disease, and that's so important about the glutamine. Thank you so much for listening.